Okay, so in this video, what we're gonna try and do is we're gonna do a few problems, and basically what I want you to try and do is to try these problems out before actually watching how it's done, but also at the same time try and notice what are the ways in which I try to apply the rules and techniques. So it's very important that you know how to apply these rules and techniques because you have seen the theorems, you have been doing them. However, now it's just about being able to apply them very well. Okay, so here's in the first question here. So it says in a triangle AEB, right? AEB is the bigger one. We have that inside there. We do find that AB is parallel to DF, right? And then they say calculate with reasons the sizes of the angles indicated with a small letter, right? So in this case, they just want us to calculate with reasons the sizes of angles indicated with small letters, meaning they are asking us to calculate x, y, and z, right? So x, y, and z. How can we calculate x, y, and z? So the first thing you should notice in this case is that since we actually have how many triangles? We actually have two big triangles, right? We have one big triangle which is ABE, and then we have one small one DFE, right? So the first thing is that in triangle DFE, DEF, um, we notice that in actual fact this 4x added with 80 gives us 8x, right? And this is the exterior angles of a triangle, right? So the exterior angles of the triangle are basically equal to each other, right? Meaning if we take 8x and we add it with the two numbers inside, which is 80 and 4x, those two numbers would give us 8x. But now, after that, why did we do that? Is because obviously we can see that if we create this equation, we'll only have x and be able to solve for x. So we'll take 4x onto the other side, we'll take 4x onto the other side, and 4x when we take it onto the other side, it will actually subtract 8x, right? It won't just go on to the other side, but we'll subtract 8x, and so it would give us 4x. And then from 4x, then we divide by 4 on both sides, and then we get 20. Sorry. So x is equals to 20, and then automatically, since we have x is equals to 20, now the only thing we need is z and y. But now notice that y is within the triangle DFE, right? So you can actually say that, okay, I actually have 4x, right? 4x, 80, and y that is equals to 180, and these are the sum of angles of a triangle, right? Or the interior angles of a triangle. And so then we place in the values that we have for x, which is 20, so it's 4 times 20 plus 80 plus y, that gives us 180, and so that would give us 20, right? So as you can see, that would give us 20, right? Now if that is 20, and basically we've actually done almost everything, but basically you need to think about a grade 9 theorem that you have used quite a number of times, since you actually have that AB is parallel to DF. So in actual fact, for Z you could say it is corresponding, right? It's corresponding because AB is parallel to DF, and that's what you actually find that 18, right? Now we move on to the next one, and in this one here, it says in the diagram below, we actually have a parallelogram, and PQRS is given with Q, the angle Q, which is 114 degrees, PT bisects QPS, and TS also bisects PSR. And they actually say prove with reasons that PT is perpendicular to ST, meaning it has a 90 degree, right? But now, the first thing about these types of questions again is that sometimes the information that they've given you at the beginning, you should try and indicate some of the information that you could use, right? So in this case, when we have a parallelogram, this means this is parallel to that, and also that one here is parallel to the other one on this side, right? That's the first type of information. But not only that, we know that this is equal to that, and this would be equals to that one there. Okay, so that's just some of the properties of a parallelogram, right? And we should know those properties of a parallelogram, so it makes it easier for us to actually find the solutions, right? But now, what we're trying to do, right? We're trying to prove for PT to be perpendicular to ST. But what does that mean again? It means that for that line PT, for this line PT, and this line ST, there has to be a 90-degree in the center there. So how could we do this? Now, well, there are ways that you could have done it. If you think about it, you could have used Pythagoras, because remember, if you're able to prove the equation of Pythagoras, then that also implies perpendicularness, right? Or being right angled, right? Proving that PST is a right angled triangle where PS would be your hypotenuse. But that would be a bit impossible because you don't actually have values for that. But what you do have, you actually were given the angle Q. So the angle Q is this one over here. So it's 114 degrees. Right. So what can we do about that, right? What can we do about that? Because we want PT to be perpendicular, meaning 90 at T1. So basically, if we can find S1 and P2, so if we can find S1 and P2, so here's P2 and S1, if we can find these two angles, and then we say angles of in a triangle and solve for PT1, we will be able to solve the problem, right? But let's begin with Q, right? So now Q is actually equals to S, but entire S, not just S, S1 or S2, but the entire S, right? However, we were given quite specific information that ST or TS basically bisects PSR. So PSR, it basically bisects it. So if it bisects it, what does that mean? It means it cuts it in half. So it cuts it in half. So 140 divided by 2 would give us S1. And that's what we did here. So we first noticed that Q is equals to S, which is 114, which are opposite angles of a parallelogram, right, which are being equal. But then to get S1, we know that we just need to divide 114 by 2 to give us 57, because TS bisects PSR. And then from there, notice that as I had placed all the properties of a parallelogram, that we want now to see what would P be, so that we can actually use the same argument, because we know that PT does bisect QPS again. So it does get bisected. These two angles here are half of each other. I mean, yeah, are half of the whole angle. It's half of the whole angle. So then what we do is, okay, we use 114 and we add it with P, right? And when we add it with P, we basically say this is co-interior angles, because we have two sides which are basically parallel, which is QPA, which is parallel to SR. And this is from what property? The property of being that it is a parallelogram. And then from there, we just solve for P. But for P, it's 66 degrees, right? So the entire thing is 66 degrees. However, because it bisects the information that it's given us, then it divides it, and therefore we get P2, which is 33 degrees. And now we've actually arrived at where we want it to be. So now we say, no, in triangle PTS, we have T1 plus S1 and plus P2, which gives us 180, which are sum of interior angles of a triangle, right? Therefore, then you just place in 57 and 33, what you'd find that would be 90, and so 180 minus 90, and so T1 is equals to 90. But since T1 is equals to 90, then obviously we have just proven that PT is perpendicular to ST, right? So hopefully that made sense. But again, the information that you've given is very important. So try your best to always highlight some of the information that you're given, that it could give you a good clue, but also at the same time, be careful of such things about bisections and so on, right? Okay, the last one here. So we have ABC, which is a parallelogram. So they say DE is perpendicular to FD. Then they say prove that BEDF is a parallelogram. Give reasons for all your statements. Okay, so now as you can see the diagram, it looks a bit complicated in terms of how can you prove that BEDF to be a parallelogram. But what we do know is that with parallelograms, if we can prove that all the sides are equal, then it's a parallelogram. Opposite sides are parallel, then it's a parallelogram. But I think the opposite sides argument would not work for the simple fact that we don't have angles, right? Measurement angles. Would have been better if we did have measurement angles, would have made life a bit easier. However, because we don't, let's rather approach it with with a bit more ingenuity. So, what can we do? What we can do at this point in time is to actually prove that this triangle here, this is AEB and DFC, to be congruent. So let's prove that it should be congruent. So automatically, the bigger shape, which is ABCD, is a parallelogram, meaning that this angle here is supposed to be equal to that angle there. Therefore, we have A is equals to C, which is opposite angles of a parallelogram, right? And then the second reason is that obviously because of the simple fact that, as I said, ABCD is a parallelogram. This side is equals to that side. It's part of the properties of a parallelogram. So then we have AB is equals to DC, opposite sides of a parallelogram. And then we can show that, okay, we have now a bit of a problem. We just need one more reason, right? So what I said was, okay, we have that for E1 is equals to B2. Why? E1 is equals to B2, and this is basically alternating angles. But B2 is equals to F2, if you notice, by corresponding, because DE and FD are parallel, if you remember those theorems from grade 9 of corresponding and alternating, and that's what we find. So therefore, since we have E1 to be equals to B2, but also B2 here, sorry, not B1, but B2 is also equals to F2, then we can equate E1 and F2 to be equals to each other, and therefore we have actually angle, 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 side reason for congruency. And then since we've proven congruency, what does that mean? It means that basically then DF in the triangle on one side is DE, sorry, on the triangle on one side is the same as the length of FD. So these are two opposite sides which are equal, which is good. Therefore, if you notice that when we've done that, clearly, automatically, then ED is equals to BF 100%, because this length there and that length there and this length is all the same. So whatever is left over here, it's definitely the same as the one that's left down there. So therefore, then we've proven that it is a parallelogram, and so the opposite sides are equal, and that is the reason that makes them a parallelogram, because we just proved that this and this would be opposite sides of a parallelogram. So other than that, I really hope that this was helpful, and I really hope that you had tried out these problems before watching the solution. Other than that, I'll see you next time.